Johns Hopkins University junior Tiras Lin is working to improve the next generation of bio-inspired, insect-sized flying machines called micro-aerial vehicles, or MAVs, by studying how butterflies maneuver with grace and agility.
One area that is lacking currently in modern micro-aerial vehicle design is their maneuverability. So we look to nature for inspiration. What can we learn from the flight of an insect? And specifically for this lab, the flight of a butterfly.
Lin's research has been supervised by Rajat Mittal, a professor of mechanical engineering at Johns Hopkins.
In the last about 10 or 15 years, there has been a recognition that while we engineers can really design big things very well, big aircrafts, big ships, when it comes to designing small things, in fact, we are fairly deficient.
To counter the lack of maneuverability of these bug-sized robots, Lin has turned to painted lady butterflies to understand what can be learned from the dynamics of insect flight.
We know that butterflies are able to do very complicated aerial maneuvers, and it's very hard to see with the naked eye, which is why we have to record them in high speed.
Working with graduate student Ling Xiaosong, Lin focused 3 high-speed, high-resolution video cameras to mathematically document the trajectory and body conformation of the butterflies. The 3-dimensional arrangement of the cameras allowed researchers to capture the data in a computer and analyze the movement of the insects' wings and bodies in minute detail.
With these frames that we've acquired, we're able to analyze them on the computer using an algorithm called direct linear transformation. And that allows us to very precisely quantify the wing flapping motion of the butterfly and also its body deformation.
Lin discovered that, like a spinning ice skater, butterflies alter their moment of inertia, a property associated with mass distribution.
Athletes such as ice skaters use a quantity in physics known as angular momentum. When they want to complete a maneuver or they want to spin very quickly, what they do is they'll tuck in their arms very close to their axis of rotation, and that allows them to spin very quickly. When they want to slow down, they stick their arms out. From our research and our subsequent analysis, we found out that the butterfly does use its wings in a way similar to the ice skater, and it changes its distribution of mass to facilitate maneuvering.
This will change the way researchers look at the dynamics of insect flight. It will change the way we analyze the capabilities and performance limits of the small flying robots.
Lin feels that his discovery should be considered by MAV designers, and that it may be useful to biologists who study insect flight dynamics.
So what we hope to do is really to unravel the secrets that go behind the dynamics of insect flight.